permeability of the mitochondrial membrane. Now, mostly they act as an anti-apoptotic protein. Now, if there is DNA damage or another apoptotic signal is received, then another family of proteins called the BAX or the BAX will go into the mitochondrial membrane and create channels that allow the contents of the mitochondria to flow out. So let's review. BCL2, anti-apoptotic. BAX or BAX is pro-apoptotic. Again, that BAX is letting the contents of the mitochondria out. So what's in the mitochondria that's so bad for cells? Well, the answer is cytochrome C. Cytochrome C will then start a cascade of enzyme activations that will end up activating caspases, which we talked about earlier before, and that again is going to lead to apoptosis. First, there are the death signals. In the cell membrane, there are two different receptors that can receive those death signals. And this includes the TNF receptor and the FAS receptor, also referred to as the CD95. So they will be activated by either TNF alpha or by the FAS ligand, respectively. Now, once activated, the receptors will transmit signals that will again cause activation of caspases. Now, another extrinsic mechanism occurs when killer lymphocytes, mainly cytotoxic T cells, recognize a cell as foreign or infected. So these lymphocytes will then release perforin and granzyme B. So what do? Well, perforin will punch holes in the plasma membrane. Remember, perforin will perforate. That's the way I remember that one. And then that granzyme B is going to enter into the cell and activate the caspases directly.
Hey everyone, welcome to our very first Lewis Notes, and Lewis Notes are what we're going to use some throughout this course in order to really knock home some of our highest yield stuff. So what I like people to do is break out their own piece of paper and write in some of this stuff yourself, because the more you put it into your brain, especially if you're writing it, the more likely that you are to retain it. So we're going to do a matching game, and you'll see me do a lot of matching games throughout the course. So here we're looking at our intrinsic and extrinsic, and we boiled it down to the most important stuff, and we're going to do a matching game here. So let's start with the intrinsic pathway here. So first we have the anti-apoptotic stuff. Remember, anti has 4 letters in it, so that's going to be our BCL2, and we're going to put that right over there. What about our pro-apoptotic stuff? Remember, that's going to be our 3-letter one, so that's going to be BAX. So if something activates BAX, then you're going to start this whole cascade down. So if you get BAX that's stimulated, you're going to get an increase in what? Remember, this is going to be the increase in mitochondrial permeability. And you don't want to do that, because once you get mitochondrial permeability up, you're going to start spewing cytochrome C all over the place, and that's going to lead to further initiation of apoptosis. Now let's move over here to the extrinsic pathway. And first we have our death receptors. That sounds like a cool band name. So our death receptors, the first one we have here is the TNF receptor. And if that gets stimulated, then you're going to run into problems. The other one that you need to remember is the FAS receptor, also known as CD95. Now, the other way that the extrinsic pathway can work is through killer T cells, so those cytotoxic T cells. And it's going to use things like perforin. Remember, you're going to use perforin here, and that's going to put holes in the plasma membrane. Then the plasma membrane is wide open for granzyme B to sneak on in. That granzyme B is going to go enter in the cell, and it's going to lead to activation of caspases. And then those caspases are going to then promote apoptosis. So if you can remember all that stuff right there, then you're going to be good to go on the intrinsic and the extrinsic pathway.
P53. So P53 is a very important player in DNA repair. Now, if DNA damage is present, P53 will arrest the cell in stage G1 of the cell cycle. So this will actually allow time, it's just stalling, for the DNA to be repaired by repair enzymes. Now, if the damage is irreparable, then P53 will then activate mechanisms that will then again lead to apoptosis. Now, P53 is often referred to as a tumor suppressor protein, because if P53 is dysfunctional, then this can lead to tumor formation in cancer. So the first one is coagulative, and coagulative is characterized as kind of a gelatinous substance in dead. Next we have liquefactive. So this is a viscous liquid mass